All right, so we're going to start a new chapter, and it's called Derivative Application. It's how we use derivatives to help us figure things out and tell more about a polynomial. So today we're going to learn about how we use what's called the first derivative test to determine relative extrema. And when you say extrema, it just means maxes and mins. So how can we use derivatives to help us tell where there are maximums and minimums on a graph? So the do now says this: for any given polynomial, describe why a max and min happens. So if you think about a max and a min, let me draw a little sketch here. So if we have an axis, let's say it's like this, and I'm going to sketch a little polynomial here. So we have a polynomial like this. Okay, so we look at this and you could tell there appears to be a maximum point and a minimum point. Okay, and how do we know this is a max and how do we know this is a min? Well, we use our eyes, but what if we don't have this? Well, what can we tell about the function here? Well, let's think about what we've been learning about, and we're learning about derivatives. And derivative, remember, derivative is just the slope at a given point, right? So let's look at points. When you have a turning point here, what is the derivative of the tangent line at this maximum point? And if you think about that, it's 0. What about the minimum point? It's 0. So we can determine where these, what we call critical values, these critical points, where they are by finding out when is the derivative 0. And that's going to help us to find those points. But now how do we tell if it's a max or a min? Well, think about this. What is the slope of the tangent line? Let's look at this point here. And we look, it's positive. What about this point here? The slope of the tangent line is negative. Okay, so if the slope goes from positive to 0 to negative, that means it was going up and then the function was going down, so it had to hit a maximum. And similar on the other side here, let's pick a point here. Slope of the tangent line, negative, derivative is negative. Derivative is positive, and you can see a negative and a positive are going to meet at a bottom minimum point. So we're going to use what's called the first derivative test to help us out. Okay, so this is going to tell us, the derivative is going to tell us where it changes from negative to positive, or positive to negative is going to tell us max or mins. All right, I'm going to shrink this down a little so we have some room. There we go. So let's fill in some stuff here. It says, if a function is blank, then we know that the first derivative is blank. So if a function is increasing, then we know that the first derivative is positive. And if a function is decreasing or going down, then we know that the first derivative is negative. Okay? Now, the slope of a horizontal tangent line. What's the slope of a horizontal tangent line? It's 0. And a tangent line will be horizontal when you are at a relative max or a relative min. Right? So you're at one of the extrema, we call it, the high or low point, like a peak or a valley. Okay, so when the slope is 0, you're either at a max or a min. We're going to use that for now to help us out. Okay, so the first derivative test, we call it, uses possible extrema, also known as critical values, to determine if there is a change in the slope. So let's take a look at an example here. We have x squared minus 4x minus 5. So first off, this we can kind of cheat a little bit here. Okay, we know by end behavior, since it's even and positive, and this is really, we can only do this if it's second power or third power, so don't get used to this, but it's definitely going to be a minimum, right? Because it's got to go up and up, so it's got to hit a minimum point. Now, don't rely on this, because first off, this doesn't tell you where it is, and it doesn't tell you, and you can't always do this. It doesn't always work, but we know it's going to be something like that, okay? So first thing we want to talk about is what? Well, let's do the first derivative test, okay? Let's take the derivative of f of x. So if f of x, I'm going to rewrite it down here, is x squared minus 4x minus 5, then f prime of x is 2x minus 4. Okay, now we want to know, when is the slope of the tangent line 0? When is it going to be at one of those turning points? So we're going to set the derivative equal to 0. And we could solve this. 2x equals 4. x equals 2. 2 is this point, this critical point where the turning point is going to occur. So the way I like to do this, we call it, like I said, we call it the, sorry, just give me one sec. We call this the first derivative test. Is what I like to do is I like to set f prime of x, and then a line, and then f of x, like this. Okay, and we set a number here. We just put the critical values on a line. Here we only have one of them, 2. Okay, so now what we're going to do is you're going to pick a number to the left and to the right of 2 and substitute it into the derivative. All right, so let's find f prime of, let's do 0. So f prime of 0 is 2 times 0 minus 4, which is 0 minus 4, negative 4. So the slope at 0 is negative 4, the slope of the tangent line. So that means it's negative, which means the function is decreasing. I like to just draw a little decreasing. And now, you might be able to predict what's going to happen on the other side. What happens when you plug in a number greater than 2? So let's find f prime of 3. 2 times 3 minus 4 is 6 minus 4 is 2. So the slope is 2 at that point. It's positive, which means it's going up. So if the slope is negative to the left of 2 and positive to the right of 2, which is kind of what our picture showed, negative slopes of tangent lines, positive slopes of tangent lines, that means we're going to have, at this point, a minimum. And it doesn't ask me, it kind of does actually. So how do I now know what that minimum value is? Well, we know the minimum occurs at 2. Take 2 and plug it back into f of x. So what is f of 2? Well, that's 2 squared minus 4 times 2 minus 5, which is 4 minus 8 minus 5, which is negative 9. So now if we want to do a little sketch of this, we could say at 2, negative 9 is the turning point, and it's going up. Now, if you wanted to find out what the points it crosses at, you could factor the original and you could find out what those are, but where it doesn't ask us to do that. Okay? So let's fill in some information here. F of x is increasing on what interval? When is it going up? When is the function increasing? Well, it's increasing to the right of 2. So it's increasing from 2 to infinity. We don't need to include 2 because it's not increasing at 2, because the slope of the tangent line or the derivative is positive. F of x is decreasing on the interval from negative infinity to 2 because the derivative is negative. So there is a relative minimum of negative 9 when x is 2. And there is the first derivative test. Take the derivative, set it equal to 0, find the critical values, and then find out what is going on each side of those critical values. Okay? So I'm going to do 2 more with you guys. All right, let's do another one. Example 1. Given the function f of x equals negative x squared minus 6x minus 2, please determine the following. Okay, so f of x is increasing and decreasing. We have to do the first derivative test. So f of x is negative x squared minus 6x minus 2. So f prime of x is negative 2x minus 6. Okay. And that means set that equal to 0. When is the derivative 0? Negative 3. So negative 3 is our critical point. So we're going to do f prime of x, f of x, and we're going to set negative 3 as the critical value. Okay? We're going to plug in a number to the right, we're going to plug in a number to the left. Doesn't matter, just show your work for each one. So what's f prime of? Let's go to the left first. Let's do negative 4. So that's negative 2 times negative 4 minus 6, which is 8 minus 6, which is 2. So the slope at negative 4 is positive, so it's going up. Let's plug in a number to the right. I'm going to do 0. It's easier. So you get negative 2 times 0 minus 6, which is negative 6. So you get negative, so it's decreasing, which means there is a maximum. It's going from increasing to decreasing. So we can fill in this table up here. It says f prime of x is increasing when? It's increasing from negative infinity up to negative 3 because the slope is positive, and it's decreasing from negative 3 to infinity because the slope is negative, which means there is a relative max when x is negative 3. If you want to know what that is, plug into the original negative 3, which is negative negative 3 squared minus 6x minus 2. It's kind of annoying. Negative negative 3 squared minus 6 times negative 3 minus 2, which is negative 9 plus 18 minus 2, which is 7. Okay, let's do one more example with each other, and then I'll let you guys try the last one on your own. Example 3. Identify all intervals where the function is increasing or decreasing and find any relative extrema if they exist. So now we got a third degree polynomial here. If you think of a third degree polynomial with a positive lead coefficient, it's going to be going down, it's going to be going up, and there's some stuff in between. So what are these max and mins? Now we can find them. So here we go. Derivative, nice simple derivative here. Derivative is 3x squared minus 6x minus 24. So when is this 0? So we set the derivative equal to 0. 3x squared minus 6x minus 24 equals 0. And now we have to do a little factoring. GCF, right? Divide everything by 3. So we get x squared minus 2x minus 8 equals 0. X, some product, what adds and multiplies, x minus 4, x plus 2. So we get critical values of 4 and negative 2. Okay, so now when we do our first derivative test, f prime of x, f of x, we're going to have multiple critical values here. We have to check negative 2, 4. What we're going to have to do now is we're going to have to check 1, 2, 3 regions. We're going to have to find the derivative between in 3 different regions now. To the left of negative 2, to the right of 4, and in between what's happening to the slope. So we're going to have to plug in 3 different numbers. F prime of, pick a number to the left of negative 2, let's do negative 3. Now, just a hint, it's a lot easier to plug into the factored form rather than this up here. So you can just plug in to here. Negative 3 minus 4, negative 3 plus 2. And this will be a lot easier because watch what we can do. We don't even have to find the numbers. Negative 3 minus 4, it's a negative, negative 3 plus 2, negative, negative times a negative, positive. See what we did there? Instead of finding out what the actual value is, it doesn't matter because it's going to be a negative number times a negative number, which is a positive number. So we get positive in this region. Now check something in between negative 2 and 4. Let's find f prime of 0. So you get 0 minus 4, 0 plus 2. That's a negative number times a positive number. Negative. So that means it's going up, down. So this point right here is a max. And then what's happening here? Let's see. Going to have to shrink this down for some room. F prime of a number to the right of 4, let's do 5. So that's 5 minus 4, 5 plus 2, which is positive, times positive, which is positive, which means increasing. This is a minimum. You want to find out what those values are, plug in negative 2 to the original, plug in 4 to the original, you will get what those points are. I know it says to do that, but to save time, I'm not going to do that for you guys. Okay? So what I want you guys to try is try the rest of the sheet, 4, 5, and 6.